Okay, today is 8.2, day 2, and what we're doing is more with logs, and basically I'm going to give you a couple expanding and condensing problems to start the hour, one of each, and we'll see how you do on it. And last hour it kind of demonstrated why we aren't just moving on, because only when I asked who thinks they've got these right, only 4 people in the room thought they had them right. So these are obviously something that takes a little bit of practice. So today's kind of a review day. Yay. Would you shut the door for us, please? Thank you. All right, so here's the first two I want to give you where you expand and, remember, it's always expand and simplify. Okay, so here's log base 5 of 125 y to the third all over x squared. Expand it as far as you can, expand and simplify. Then the other one is already expanded. 5 log base 3 of m minus 2 log base 3 of p minus 4 log base 3 of MP. You're meant to condense that all down. Remember, it's condense and simplify also. That's not the question. The question is, can you condense what you've been given? Okay, so condense. On the red one, you're condensing. All right. See if you can feel confident on those two answers. I'll pause while you give it a shot. So let's see how you did. This one has got a divide in it. That means that you're going to be changing that to a subtract. It's also got a multiply in it. You're going to be changing that to an add. All right, so let's get started. Mr. GK, tell me how to start. Base 5. Nope, log base 5 of 125. Okay. Okay. And we do want to split those up eventually, but that's an okay way to start. And then what? All right. Now let's just right now do this other part. Can you tell me what to do with that y to the third? Mm-hmm. Excellent. Now let's move on. Mr. Purple Shirt. What do I do?
Well, I knew that 5 to the third power.
Yes.
Reduce that to 3.
This whole thing becomes a 3. How many of you caught that? Raise your hand if you did. Okay, good. Then
I knew that the 3 and the y moved to the front. So
why can't you just leave it that way? What you do when you check is you check and see, is this argument thing, is this part right here, can that be broken up? And y to the third could be broken up, couldn't it? Into y times y times y. So you could technically write this as log base 5 of y plus log base 5 of y plus log base 5 of y. And so instead we take the 3 and put it in front and we say 3 log base 5 of y. I'll go over things like that multiple times just because for some kids that moment right there, that was the first time they understood what is happening with that 3 going down to the front. It's really because it's y times y times y. All right, keep going.
And also the same thing on the other side. Put the 2
Now, how am I supposed to check to see if I'm totally done? You look at the arguments, that and that. Can they be broken up more? No. Another thing you look at is, can the bases go with the arguments and somehow simplify? No. And no. So then I'm done. That's it. Who had this one perfect? Ooh, good, a lot of you. All right. Now the contraction or the condensing part. Mr. NG, tell me how you'd start. Mm-hmm. So the 5 goes up here. I agreed. Let's do that on the other ones too.
And then the 2 went up to the exponent.
Yep. So you could either go like these together and put a 4, or you could put it on both of them. The common mistake is to just think I'm going to put it on one of them. And then what, are you just going to pick a random one? You can't do that. So you get 1, 4 on each of them. I'm going to do it that way. You could have done it as quantity with 4. All right. Now, pick somebody to hand it off to. They have to finish it from there. All right. Good. Mr. L. Log base 3.
And then you put M5.
M to the 5th.
On top. And then you divide it by P squared.
Correct.
And then, okay.
Keep going.
And then you put MP to the 4th power.
Yep. False, but close. Would you agree that this implies divide? Again. Then I need to have another divided by M to the 4th, P to the 4th, which we could put as MP to the 4th. So then that means you would divide that by 1. It's going to still flip and multiply, and you're going to end up being right by accident. Okay, because it won't do it the reason you thought, but because it's divided by this fraction, that ends up being multiplied by flip it, and they will be on the bottom after all.
I did that on purpose.
Yeah, I'm sure you did. Okay, so if you said log base 3 of M to the 5th over P to the 5th, but then I got to do some canceling. Remember, it's expand and simplify and condense and simplify. Do you get that there's some canceling can be done in there? The M's. So therefore, it's just 1 M left on the top over P to the 6th. There you go. Oh, I got you. Because, yeah, I got you. You thought it wasn't going to go there? Yes? Oh, do you mean if you didn't simplify? Then if you had left it as all of this, not full credit at least. If we get full credit, you have to condense and simplify. So I would agree that it seems like it deserves some partial credit. So it all depends whether it's homework, if it's a test. We're pretty ruthless because you can get, you can make your mistakes, but not on every problem. You can make one mistake per set of R2s and one mistake per set of R3s and not get penalized. Yes?
So if you were to expand that back out, it would...
I get what you're saying. If you expand that back out, it'd be different than it was in the first place. But it's kind of like saying, if I get an answer all the way down to 1/2, can you expand that up and know what it was in the first place? Do you know if it was really 5/10 or was it really 200 over 400? I don't know, but it simplifies down to that. You know what I'm saying? Okay. All right. So, how many of you would have gotten 2 out of 2 on this little mini quiz that I just gave you? All right. How many of you would have gotten 1 out of the 2 right, at least? Okay, good. That's almost everybody got 1 of the 2. All right. So, obviously, it seems to me like you guys are much better at expanding than you are at condensing, at least when it involves lots of divisions. All right. So that gives me a little info to help you do better here in how I teach you this stuff. Number 1, 2, 3, 4, and 5 are all wrong on this page. The question is, what should the answer have been? People do this and they think, oh, so I can split this up into log base 5 of x plus log base 5 of y. Totally not correct. Do you get if it had been a multiply right there? Then you could change it to an add. That's the kind you can split apart. Kinds that are multiplied in there. People forget that when they see this, they just think, I could bet a lot of you might have thought that seemed okay, but it's not. Okay, so what is the right answer? Well, you can't split that up. So it's already simplified as it can be. So I guess you could rewrite itself, log base 5 of x plus y. You can always do the base change if you wanted to. You know, like we could change the base to like base E or base 10. Remember how to do that? How about if I make that the question? Make this true by making it a base change to base 10. It's kind of like saying, how would you put this in a calculator? Here's a simpler base change in case you forgot. Log base 3 of 8. Put that in a calculator, you go log 8 over log 3. Remember that base change deal? Log base 3 of 8 would change to log 8 over log 3. That's a base change. It changed from base 3 to base, there's no base, which means base what? Base 10. Okay, that's how you do base change. I want you to see if you changed it to base 10 the same way as the person next to you did. So comparing your left-right kind of partners, compare and see if your base change is the same as theirs. Making it base 10. The way I like to do this is actually not to pick the base ahead of time. I'll just say log, which of course means base 10. Log of this over log of that. There we go. And then you can pick any base you want. I just happen to say base 10, so then you're done. That's it. You don't even have to write the number 10 down here. It's implied. What if I had said make it log base E? I just made this an E and made that an E. You can use any base you want when you do base change. Because the numbers are just getting proportionally bigger. Both of them get proportionally bigger. And then if they both get the same amount bigger, the same ratio bigger, then the ratio stays the same. So anyway, you can pick any base you want right there. All right, let's move on to number 2. What should the answer have been? Don't say it, write it. That's not what the right answer is. That answer implies everything is getting cubed. Not everything is getting cubed in the problem. Mr. DH.
Oh, it's me.
I don't know. There's another one. There's another designated hitter in here. All right. I'd like it if you threw in one more word. 3 log base 2 of x. You are correct, sir. Raise your hand if you had that one right. Okay, good. On to the next one. Do you get that you can't make a divide into a divide? All right. If I was going to just tweak their answer a little bit, do you get that I could say that would be true? Think of it as a base change. It's log of xy, x over y, sorry, over log of 10. But that's kind of cheating because what is log of 10? It's log base 10 of 10, right? And what's log base 10 of 10? It's 1. So it's basically just dividing it by 1. So, all right. Well, it definitely isn't what they said it was. All right. Moving on to number 4. It's kind of like if you won the argument, you get nothing, except this is just completely wrong. Why is it completely wrong? Yes, sir. Good point. If you rewrite this, you'd be saying 13 to the first is equal to 0. Not true. And another way to say it is, you can't have a 0 right there. Do you remember that? Not allowed to have zeros there. You can't have a 0 right here. Remember how these can't be negatives or zeros? They have to be bigger than 0. What's that one other restriction about these? What can't be 1? The base. The base can't be 1, but we didn't break that rule. We broke this rule. That's right there is not supposed to be 0. Okay, how about 5? Miss Z. Tell me. Actually, that's not fair. Because last time only one person in the whole room figured it out. Everybody try to figure out what this should be. We know it's not right. What could you make that into that would make it true? Okay, good question. What that means is 3 to the power of, I'll make it in parentheses, 5 log base 3 of x.
Yeah, ours it's written differently. The 3 isn't in the 5. It's 3 to the 5 log x.
Oh, that's totally different. Yeah, you're right. Okay, we're going to stick with the one that I have on the board. See if you can figure this out. It's equal to something, but it's not equal to 5x. Ooh, what do you think? It does have an x in the answer, but the answer is not just x. I get what you're thinking. You're thinking, oh, well, there's a 3 here and there's a 3 here, and so maybe x is the answer. Well, it's kind of part of the answer. And I get why people think it would be 5x, because they think if these two are the same, then that's the answer, right? So the answer should be x, but I'll just multiply it by 5. Nope, doesn't work that way. But it's close. Ah, some people have put it together. Raise your hand if you think you have it now. About half the class. What do you think, Mr. L? X to the 5th is correct. Think about it. I'll give you a simple way. If that 5 gets put up onto that x, then it'll read 3 to the log base 3 of x to the 5th. And then this and this is the same, and so that's the answer. All we did is move a number from the front to the power. Okay, good enough. Those made you think a little bit. The homework for today is a lot like, it has a slide rule thing on this slide, or in this presentation, but I don't know how to use a slide rule. So we are not doing that part. I can tell you this, a slide rule is what they used before calculators if they wanted to do logs. The very first mathematicians that did logs, they had a big chart. They'd look it up on a chart. Like in the back of a textbook, they could look up log of anything. It was all a big chart. Imagine how many pages that took. Then they got this thing called a slide rule. Somebody smart figured out how they basically put the chart onto this. It's not exactly the chart, but you could look it up on your slide rule by lining up this and this thing. As you slide this thing, you could get the answers for like log. But I haven't been trained how to do that, so we're just going to let that go, which means there's a couple problems we'll have to skip in the homework because it asks you about slide rules. So, yes, sir? Good question. There were, it's not like logs existed at the beginning of time. Some guy figured out that we could do logs, and as soon as he figured out, I don't know exactly how the process worked, but the next logical step is, okay, well, there's going to be some logs that you can't do without a decimal, and so, like, I'll have to have a chart for this. I don't know the history of it. I'd like to know. Something I'll be better at next year, but all right. This one, skip. And on this page, let's start it together. This is day 2's homework. Number 4, the very first one. Mr. W. Tell me, I could break this multiply. Any multiply can be broken up into an add. So can you tell me how to rewrite this? We'll just keep using base 10 like they have now.
Log of
I'm just going to say base 10.
1.2
Mm-hmm.
plus log
Do you get why writing the base was smart? Because now all of a sudden you see, oh, wait a minute, these are the same. And so what's the answer to that last part? 37. So the answer is expand and simplify, right? Here's the part we can simplify. That's just 37. Now, does anybody can do that in their head? I'm doubting it. Log of 1.23. Okay. So if we wanted to know what it was, we could say it equals x, right? And we could say 10 to the x equals 1.23. So it's like saying 10 to some decimal power would equal 1.23. Not coming to me. I can leave it alone. The answer is just 37 plus log of 1.23. Some of these, of course, you're not going to be able to figure out in your head. All right. Next up, log. Let's do number 5. ln, right away, do you remember my advice about ln's? Rewrite them as log base e. Okay, so that's log base E of, square roots. Probably be smarter to write that a different way. Yes, Z to the 1/2. Only appropriate that you would be the one to figure that out considering the letter. And then it's over XY. Now, could I expand this out? Yeah, I may as well just not say divided by XY. Instead, divided by implies subtract, right? Minus log base E of XY. Now, something's got to simplify here. That 1/2 can go where? Up in front, yep. 1/2 log base E of Z minus log base E of X plus log base E of Y. All right, now this is a really tricky part. Do you get that this part here is all together right now and there's a minus in front of it? Do you get that that minus needs to distribute to both parts? So it's going to be minus log base E of X. And normally you'd say plus, but now because there's a minus out front, that negative has to distribute to that. And it'll say minus log base E of Y. All right, and since our arguments can't be split up anymore after we do that, and our bases, like the E and the X, can't just go together, then we'll have to leave it that way. Sometimes they don't simplify much. Yes, sir? Yes, you could write it this way. Minus parentheses log base EX plus log base EY. And that, at least because there's a parentheses, the people that are after you would have to know that, oh, so you could have distributed the negative both of them. Yes. Yes.
So after you distribute the negative, do you still have to put parentheses around it?
Nope. If you distributed the negative, then there's no more need for the parentheses. Okay. So I think you get the idea. Some of these have lots of square roots in them. You immediately change the square roots to power of 1/2, but what if it's a cube root? Power of 1/3, it's no big deal. Okay, good. And then notice anytime you have a ln in your problem, you're thinking, is there any e's in it that could cancel with the base e that I have? And I don't see any in that one. But how about in this one? What's its base? It's got a base 10, and there's 10s running all over the place in the argument. So you probably have a bunch of simplifying you can do on that one. Once you get it all stretched out, just remember, if it don't show the base, when you do the problem, you write the base. And you'll see, oh, I see one in the base and one in the argument, and I can make them like simplify. All right, move on to this page. And they're all such like important problems, and they all do such different things. I can't have you skip any of them, 18, 19, 22, or 23. The challenges, of course, are always optional. And it's always good to stretch yourself. It's kind of like lifting the really heavy weight at the end of the weightlifting session. It's a good challenge, and it'll make you smarter. Number 45 we have to skip because it does involve needing to know how to do a slide rule, and that's something I want to add next year, but I don't know how to do it right now. So it's not like you need to read a slide rule for your test either. So just know it's an old way of doing logs before there were calculators. These are both base change of base. So how are you supposed to change the base if you don't even have a log? Well, first thing you got to do is rewrite it as a log, right? So let's take this and rewrite it as a log. Die of destiny, who should I call that? Apparently, it's you.
Oh, great. Yeah. Okay.
Start with the word log.
The base is what stays the base.
So log base. Okay, keep going. Okay. So how are we supposed to change this to a log and then change it to the base? The base change is the easy part at the end. Can you do it? What do you think? I can start with a log base E if you want to, but I still am curious how you're going to get this to become a log. What do you think?
Log base 7 of x equals x minus 1.
Yeah, but you're assuming that the answer to this has to come out to x. You can't throw in another x. What do you think? No, we're going with Coda. Log base e of 7. Okay. Now what you're doing there is you're taking the exponent and saying, I don't think you can do that. Now, I want to like write your answer down just in case you turn out to be right when it's all done, but I don't think you can do that. But I'll try to note that you thought it was that in case it simplifies down to that, and then I'll have a new genius way to do it. Yes? You have an idea? Okay. What do you think? Log base 7 of y. Okay, so you're basically setting this whole thing equal to y. So like we don't know what it equals, but it equals something. Well, that seems like we should be able to try that. So then log base 7 of y, this unknown thing, is equal to x minus 1. It's not base e yet, but that's okay. We can do a base change on it to make it base e. But we still have this extra y thrown in there. Let's see if it goes away as we go further. All right. All I'm thinking right now is to figure out what the y is. Well, I know I can change it to base e pretty easy. I can take anything and make it base e as long as I have an equation. So I could just say that this is log y over log 7, and then I can just make them both base e. Nothing wrong with that except I have this unknown y thing in my equation. I'm stuck. I don't know how to do this one. I'm not saying I can't figure it out, but...
I got it.
Okay, yes?
So you do it.
It's okay. It's okay. This is what you do. This is exactly where it'd be okay. You don't want to like sit and agonize over a problem for 4 hours before you eventually die from eye strain. You can just, it's okay. We struggled with it. Yes, wait, you got an idea without the key? Okay, without looking at the key, what's your idea? You can't subtract x minus 1 here and subtract. I get what you're saying. If I subtract x minus 1 here and then subtract x minus 1 here, it wouldn't subtract from the y, though. I could set the whole thing equal to 0. That's true. But I like subtract it from both sides and then leave it equal to 0, but I don't think that's going to help. Maybe it does to somebody else. Because I'm seeing a lot of hands. What do you think? Log base e of 7. Okay, I'm trying to figure out why I can do that. Okay, you did the log of that exponential, the original problem. See, this is the original problem right here, and you did the log of that original problem divided by log base e of the base. That seems like it has potential. Why can we do that? Yeah?
I wrote it like this, so log base 7 of y equals x minus 1.
Okay, wait. Let me write it down for everybody so they can all see it. Log base 7 of y equals x minus 1. Is that the deal where we just rewrote the thing?
The original one.
Yep.
And then I wrote log base e of y over log base e of 7 to switch it to base e.
Over log base e of 7.
In the first equation, y equals 7 to x minus 1.
Oh, hold on. So this y right here.
The fraction was equal x minus 1, but if you look in the first equation, the log base 7
Yep.
y equals x minus 1, y equals 7 to the x minus 1. So instead of y in the bottom fraction,
Yeah, since the original thing says equals y, right? That's what we decided to say it was equal to. Then this y right here could be replaced with a 7 to the x minus 1. I like it. That was a tough one. That's awesome. Okay, so if that's true, then I can put a 7 to the x minus 1 right here. 7 to the x minus 1. And that should be equal to x minus 1 when it's done. Right? Because we just replaced this with this.
Well, I don't know if it's equal to x minus 1, but it's the base.
All right, I can tell you this, we aren't going to conquer this one all right now. I would encourage you to look at the answer key and see if it comes up. Have you figured something out? Make it fast.
I just thought you wanted me to read it.
Oh, okay, go ahead. Tell me what the answer key says.
It says that it's natural
Log base E of
well, it's like no,
E to the power of?
e to the power of e to the power of ln.
Which is log base E of 7. Okay, that's the same thing as a 7.
Minus 1 in parentheses.
This ln
It's this right
Do you get that that's equal to 7, everybody?
Yeah.
Yeah, but then there's also an
That's just a funny way of writing 7, okay? And then is that all to the power of x minus 1?
X minus 1 is also it's log base e of 7 times x minus 1.
Oh, I get it. I get it. Maybe you don't get it yet. Do you get what's in the box? What's in the box?
What's in the box? Fruit Loop.
7. 7's in the box. That's equal to 7, right? So 7 to the x minus 1. That's the original problem. And all he did was a fancy way to replace the 7 with a log, here, e to the log base e of 7. Okay, so what's cool is what's in the box is that's a 7 to the x minus 1. And when you have two things that are powers, look, it's a power to a power. And when you have a power to a power, like a to the second to the third, do you get that you multiply those two powers? Whew! Wow!
I don't understand how they got that answer. If we read
You can take a number like 7 and you can replace it with, and in fact, if you wanted to really blow your elementary teacher's mind, it'd be like this. 6 plus 2 equals 8, and instead of 8, you go back and say, well, of course, it's actually E ln 8, because that is 8. And so that means wherever you see an 8, you can replace it with e to the ln 8, because that is 8. All right, enough. So your homework for today involves one last one that's a challenge, and that's this one. Okay, and we're skipping the ones after it. So this is your last problem, and it's kind of challenging, and it's not super hard, but you need to pay attention for our last 3 minutes here. You ready? Okay. This next part's going to go kind of fast, but it boils down to something kind of cool. Do you get that this does not have any exponents in it right now? And therefore, it's hard to write as a log, because normally you take logs and you write it for things that have exponents. But this does have an exponent in it. It's like a to the 1, isn't it? So couldn't you really say that this is log base a of the other side, BC, equals 1? Now you might think you're done right there. In fact, first hour I thought that I was done right there. But its base that they want is what? They want base 10. So now I have to just take this and do a base change on it, because right now it's base A. So then I go log BC over log A. Now do you get they both have a base of 10? But I haven't got log A alone yet. So I can multiply by log A on both sides. And the cool thing is that I know some math teachers are probably going to watch, if they were watching this video, they would say, oh, you're going such a long, painful way. Yeah, but I'm trying to show you why log BC is equal to log A. Do you get that I could have just taken the log and put one here, put one there. Log A is equal to log BC. Get it? Log A is equal to log BC. What do you mean? You can just slap a log in front of something if you want to? Not really. But what if I said A is equal to 2? Then wouldn't log A be equal to log 2? Because A is 2. So you can take the log of both sides of an equation. So if you had something like A equals BC, which is what we do have, you can take the log of A should be equal to the log of BC. That has a base 10, of course. If I wanted it in base E, it wouldn't be that hard. I'd just have to do a base change. All right. Then this log BC, couldn't that be split up into a log B plus a log C?
Yes.
And then wouldn't I have A in terms of log B and log C? Yes, I would. So moral of the story, you can take logs of both sides of an equation, and that's what you should do, and then expand them, and you'll have A, B, C, D, E, and F right. Those, the reason, sit down, you got another minute, the reason that those are hard is that that's a question from a course you haven't had yet, right? AB Calc or HL, which is an IB class, okay? Those both are calc level questions that you're, so when you see these, don't think, oh my gosh, that's impossible. It's because it's a year from now. But we're giving you an idea what those classes are going to be kind of like. These are actual questions from previous, like they're retired questions from previous AP tests and or HL tests. All right, so your homework, I graded one today, right? Wouldn't you not expect we'd be grading tomorrow? But when you least expect it, expect it. All right, that's all we got for today.